I'm Christina from Soundwaters, and I want to welcome you to our virtual field trip, part of our series on climate change. Before I introduce my colleague Jess, who will be leading you through this virtual field trip, I want to make sure you have viewed our video on greenhouse gases. Understanding greenhouse gases and how they influence climate change is an important prerequisite to the subjects in this series. So I encourage you to pause now, view greenhouse gases, and come back to learn more from this video. I'm sure you will enjoy learning all about climate change, how it affects our environment, and things you can do to mitigate the damaging effects. So, without further ado, I would like to introduce my colleague and friend, Jess.
Climate change is one of the most complex issues facing society today. There are a lot of different aspects to it, such as economics, science, society, and politics. It is a global issue felt on a local level. Human activity is the main cause of our warming planet. It's having different repercussions felt all around the world, like ocean acidification, sea level rise, and ocean warming. The ability to prepare for, anticipate, and respond to these changes is called climate resilience. To better understand climate resilience, I'm going to give you an example. Along the coast here in Connecticut, the issues that we are most concerned with are tidal flooding and sea level rise. Now, if you fly across the country to western United States, they actually have the opposite problem. They're more concerned about droughts caused by climate change. Anticipating and knowing all of the factors that will be influencing your local community are very important in coming up with a plan to combat them. Let's dive into a few different ways that people are dealing with climate resilience. A good climate resilience plan uses two different strategies: mitigation and adaptation. Mitigation and adaptation complement each other very well. Mitigation is all about trying to reduce what is causing climate change, such as reducing greenhouse gas emissions, whereas adaptation is about dealing with the impacts already being felt by climate change, such as rising sea levels. To better understand this, we're going to talk about a little example. We're in a boat, and our boat has a hole in it, and we're starting to sink. The adaptation strategy would be to bucket out the water as we're going down, whereas the mitigation strategy would be to plug the hole. So mitigating it, we're dealing with the root of the problem instead of just what's happening as the problem goes on. Let's go check out things around Long Island Sound that people are doing, both adaptation and mitigation to climate change.
When you think of kelp, you may think of those magical underwater forests or the green chips you find in the grocery store. However, kelp, in addition to being a habitat and a healthy snack, also helps to mitigate the effects of greenhouse gases. Kelp is grown right here in Long Island Sound during the winter, as well as in other salty water environments. Kelp can help permanently remove carbon dioxide from the atmosphere, which plays a critical role in preventing rising temperatures. But how, you might ask, does this plant remove carbon dioxide from the water? One way to remove or sequester carbon dioxide is using biology. When plants such as trees photosynthesize and grow, carbon, in the form of carbon dioxide, is removed from the atmosphere and converted into biomass, such as a branch or a leaf on a growing tree. Coastal ecosystems sequester away surprisingly large amounts of carbon. They can remove up to 20 times more carbon per acre than land forests. Kelp is especially great at sequestering carbon from the atmosphere because it's grown offshore, the top of the water. Since the kelp is grown away from the shore, it's less likely to be disturbed and release its carbon back into the atmosphere. Kelp have gas-filled bladders that help them float towards the surface, where they receive more sunlight for photosynthesis. These gas-filled bladders allow bits of kelp to float for long distances and be carried far away from the kelp farm. Eventually, the air bladders burst and the kelp sinks down towards the deep sea floor, where the carbon is thought to be sequestered away from the atmosphere for centuries.
While kelp is one of the best marine plants to sequester carbon, other coastal habitats can do a great job as well. I'm here in the salt marsh. The salt marsh is an awesome carbon sink, which means it's really great at absorbing atmospheric carbon. And when it absorbs this carbon, it can keep it away from the atmosphere for hundreds of years. 1 acre of salt marsh has more biomass than an acre of farmland. So the plants here, that biomass, can absorb even more carbon out of the atmosphere. And as it takes the carbon away and when it dies, it is sequestered down into the sediments. And the sediments here in the salt marsh don't have a lot of oxygen, so it doesn't decay very quickly. And that's what helps trap it away from the atmosphere for such a long time. The only problem with salt marshes is they're very susceptible to human activity. So coastal storms, erosion, runoff can have a real impact on the salt marsh. It can cause the premature release of the carbon that's being sequestered away. Another mitigation strategy to reduce emissions of greenhouse gases is composting. According to the Connecticut Department of Energy and Environmental Protection, the #1 waste going to landfills is food waste from homes. When food waste breaks down in a landfill, there isn't enough oxygen, and it produces something called methane, which is a very potent greenhouse gas. By composting at home, we reduce the amount of food waste going into our landfills, thereby reducing the amount of methane being produced by them. You can either create a big pile in your backyard or get one of these simple composters. And all you need to do is get all organic matter, so food scraps from your kitchen, sticks from outside, dead leaves from outside. You put it all inside here, give it a spin every once in a while, and it will decompose into very fertile soil that you can use in your garden. Another mitigation strategy is using renewable energy sources. Let's do a little refresher on what renewable energy is. Renewable energy is energy provided by a natural resource that is continuously replenished. And they're a great mitigation strategy because they're not contributing any greenhouse gases to the atmosphere. Can you think of any examples of renewable energy sources? Connecticut uses a few, such as hydropower, wind power, and solar power.
Wind power involves converting wind energy into electricity by using wind turbines. It all starts when the wind blows across the turbine, causing the blades to spin. This turns a generator in the torque shaft, which converts the kinetic energy of the wind into electricity. The electricity flows down the shaft and goes to a transformer. Then it goes out to the national grid where it's transported around the country. Wind power is a clean energy source that we can rely on for the long-term future. A wind turbine creates reliable, cost-effective, pollution-free energy. It is affordable, clean, and sustainable. One wind turbine can be sufficient to generate energy for a household. So where can we find wind power in Connecticut? This is the wind turbine database that was created by the United States Department of Energy Wind Energy Technologies Office, along with other partners. As you can see here, Connecticut's onshore utility-scale wind project consists of 2 turbines in the northwestern corner of the state. They went online in 2015. However, the state's best wind power potential is offshore, along the Long Island Sound coastline. There are plans to have turbines here by 2030.
Hydropower is another example of a renewable energy resource, and it's all about using water to generate electricity. This dam behind me was used to power machinery at a small factory here in Cove Island Park. Today, we have larger facilities that use water flow to generate power. They're called hydroelectric facilities. And the way it works is water flows down through a pipe and it spins a turbine, and that spinning of the turbine, similar to in the wind turbine, generates the energy. And the larger the water flow and the greater the drop, the slope the water goes down, the more power is created. Hydropower is the oldest renewable energy resource in the United States. Up until 2019, it was also the greatest generation of renewable energy used in the U.S. There are 13 traditional hydroelectric facilities in Connecticut and a pumped storage hydroelectric facility. A pumped storage hydroelectric facility involves pumping water from a water source up to a higher elevation. Then that water is released and flows down to generate the power, as we talked about earlier. Rocky River Hydroelectric Facility in New Milford, Connecticut is the oldest facility built in the United States and was completed in 1929.
Solar energy is one of the most common types of renewable energy being used by households. We can use solar power in 2 different ways, as a heat source and as an energy source. Solar panels convert the energy from the sun into energy we can use in our homes. The cells on the solar panel that do the work are called photovoltaic cells, which means light electricity. When the cells are combined together in a solar panel, they create a current that's used by us. Connecticut's solar installations have been increasing every year, and there's currently enough solar energy being generated in Connecticut to power almost 110,000 homes. The cost of installing solar has decreased 38% over the last 5 years, making it a great choice for renewable energy. The sun is always there, and even on cloudy days, solar panels still collect some energy. In fact, the sunlight that shines on the Earth in just 1 hour could beat world energy demand for an entire year.
Let's talk about the other half of a great resilience plan: adaptation. adaptation is all about reducing the vulnerability to climate change. So if we think back to our analogy of the boat, instead of plugging the hole, it's bucketing out the water. Let's go check out some examples of adaptation around the Long Island Sound watershed. As you walk along the shoreline of Connecticut, you'll notice there are many different habitats, such as we find here: rocky intertidal zones, coastal mudflats, salt marsh, and sandy beach. All of these habitats are under threat from climate change. They can be greatly altered or damaged from rising sea levels. This behind me is Connecticut's first Living Shoreline Project. And a Living Shoreline Project is defined as a management solution that aims to restore, enhance, or create new coastal habitats to help reduce erosion and flooding. The Stratford Point Living Shoreline is the Connecticut DEP's first Living Shoreline Project. It was led by Dr. Mattei, who's with Sacred Heart University's biology department. And it started off with some of these reef balls being put in 2014. After a trial round, they decided that they worked really well, so they put in some more in 2016 for a total of 337 reef balls. They're in between the mean high tide and low tide levels. And these balls are made out of concrete, and they mimic the natural structure of a reef. So what that does is it helps to dampen wave action, which helps prevent erosion, protecting the shoreline, and it also promotes the growth of organisms living in the water, like these oysters down here, and the snails and barnacles that call this place home. The project was so effective, it won the Best Restored Shore Award. Here are some photos of the project before it was started. You can see the salt marsh is much reduced and there's not a lot of coastal habitat. If you take a look behind me now, you can see that the project met its goal of reducing coastal erosion, reducing exposure of contaminants, and also encouraging the restoration of wildlife habitats. The Living Shoreline Project not only put in the reef balls at the beach, but they also worked with the dune system here at Stratford Point. In 2011, geotubes were added here to help support the dune system, and these geotubes were filled with sand and soil to help prevent the erosion of the dunes. But in Superstorm Sandy in 2012, they were eroded away. So in 2018, the project came in and helped to refortify the dunes by including a coir fiber tube. And these ones are now filled with shell fragments instead. If these weren't here, this dune behind me would collapse down. And the project also helped to plant native grass species on the dune to help stabilize it as well. Salt marshes are very susceptible to sea level rise. One way that scientists are trying to protect them from rising sea levels is by something called thin layer placement of sediments. And what that involves is collecting sediments, usually dredged materials, and layering them on top of the marsh. And this method is being used by the National Estuarine Research Reserve to try to improve the growth of their salt marshes. Naturally, salt marshes want to move up the coast. A lot of times their movement horizontally is blocked by development or by dune systems and vertical slopes. Without being able to move up the shore, they will be flooded out by rising sea levels. This thin layer placement of sediments allows the salt marsh to rise vertically, and the vertical growth will protect them from rising sea levels. Why are we putting so much effort into salt marshes? They are so important to so many different marine species. 75% of fish species rely on them at some point in their life cycle, and they provide an annual $23.2 billion in storm protection.
Over 310 existing homes in coastal communities around the U.S. are projected to be at risk of flooding by 2045. That number grows to almost 2.4 million homes by the end of the century. Across the country, communities are coming together to combat sea level rise and finding innovative and resourceful solutions. However, what works for one city may not work for another. Choosing the right solution will depend on factors like local climate, resources, both natural and economic, and laws. There are things individuals are doing, such as lifting their homes, and things cities are doing, such as raising roads and building seawalls. Let's dive into some of these methods a little further. Houses can be raised above flood levels by using 6-foot-tall wooden stilts or concrete blocks. Even if the house doesn't flood, the driveway and the roads around it still may. It's easier for a new home to be built higher, but existing homes can be raised as well. Often, rebuilding happens when FEMA, the Federal Emergency Management Agency, grants money, such as after a disaster like Hurricane Sandy. Some homeowners choose to relocate their homes, moving their existing home to higher ground. To relocate, a house is lifted off its foundation, hauled to a new site, and lowered onto a new foundation. Roads through coastal communities are at risk as well. Once identified, many vulnerable roads can be made resilient through traditional pavement maintenance cycles. These cycles include monitoring pavement health, addressing and fixing potholes, delamination and cracking, and maintaining proper pavement lane markings. Another method of adapting is to raise the road, as they're doing in places such as Miami. Raising roads above sea level can help drain water and reduce tidal flooding. In order to make sure that higher roads don't channel floodwaters to homes and those stores at lower elevations, cities often use stormwater pumps to remove this excess water. With higher seas, water doesn't drain out as easily. Pumps can speed up the process of getting water off the streets by vacuuming up the floodwater and releasing it back into the sea. While adaptation strategies are still emerging, modifications to pavement structures, such as increasing layer thicknesses and using stiffer materials, are being evaluated. Adaptation will avoid the costs of more frequent maintenance and repair and determine the most cost-effective adaptation actions. Seawalls are being built to reduce flooding from storms and tides. They're often built to a height of 5 to 6 feet above sea level. To reduce flooding, old seawalls will need to be replaced and raised higher as sea rises. This is a photo of the seawall in Stratford, Connecticut. So what's going on locally? Solutions in Connecticut can be complicated because evaluation of coastal community needs and preservation of wetland habitats must both be taken into consideration when solving for sea level rise. There are already over 7,000 properties at risk from frequent tidal flooding in Connecticut. The state is planning over $2 billion in sea level rise solutions, which include restoration projects, catastrophic flood prevention, and building seawalls.
We need all hands and strategy on deck in order to mitigate and adapt to climate change. Thinking back to our analogy, we need to be able to seal the hole or mitigate and dump out all the water or adapt in order to avoid sinking. Get involved in your local community. Learn about the resilience plan. You might be interested in what you find.